Hello. This video is for textbook lesson 2 of chapter 3, so it's lesson 3.2, where the title is Solving Equations Having Like Terms and Parentheses. Our objective is to solve equations by using the distributive property. Our review vocabulary is like terms. So in order to combine like terms, we're going to have to know what like terms are, right? So school spirit. Your school's basketball team is playing in the championship game. For the game, the cheerleaders want to buy a banner that cost $47, so that's probably an important number there. They also want to buy small items to give to students in the stands. Pom-poms cost $5, 20 cents each. Noisemakers cost 80 cents each. The cheerleaders have a total budget of $377 for the game. If they buy equal number of pom-poms and noisemakers, how many can they afford to buy? So we'll look at how solving this involves combining like terms or parentheses. So let's look at that. Example 1 is writing and solving an equation, and it relates to our pom-pom and noisemaker question. Find out how many pom-poms and noisemakers the cheerleaders can afford as described above, or described in that previous slide that we looked at. So let's look at what our solution is. We're going to let n for number, because we're looking for the number of pom-poms and the number of noisemakers. So n seems like a pretty good variable to use for that. So let n represent the number of pom-poms and the number of noisemakers. That means that 5.2 or $5.20 times the number of pom-poms is going to represent the cost of the pom-poms. And 80 cents times n is going to represent the cost of the number of noisemakers. So let's write a verbal model. Well, we know that the cost of the pom-poms plus the cost of the noisemakers, and remember, we're buying the same number of each. That's why n is what we're going to use for each of those. So the cost of the pom-poms plus the cost of the noisemakers plus the cost of the banner is going to equal their total budget. So let's bring down the cost of the pom-poms. They're $5.20 each, so 5.20 n plus the cost of the noisemakers. Well, they're 80 cents a piece, and it all depends upon how many we buy for that cost. So that's the number of noisemakers, and is represent the number of noisemakers there. And then $47, remember that is the cost of the banner, and then their total budget is $377. So in our first step here, we just substituted in from our verbal model here, we actually made our math sentence. Now we can go ahead and start solving this. So we're going to combine like terms. Notice that this is in the terms of n and this is in the terms of n. So we can combine these two. 5.2 plus 0.8 is going to be 6. So we have 6n plus 47 equals 377. The next step is then to get rid of this positive 47 with a negative 47. And what we do to one side, we're going to do to the other. So we are subtracting 47 from each side. The 47s are going to cancel each other out, leaving us with 6n. The 6n comes down here because these are opposites and they equal a value of 0. And 377 minus 47 is going to be 330. Now the 6 is tied to the n through multiplication. So we're going to use division, a fraction, to undo that. We're going to divide by the very number we wish to get rid of, which is 6. And what we do to one side, we're going to do to the other. Then we know that the 6's are going to cancel each other, leaving us with just n. And 330 divided by 6 equals 55. So our solution is that n equals 55. And remember that n represents the number of pom-poms and the number of noisemakers that we're going to purchase. And we used that set up like this because we're going to purchase the same number of each of them. So in the end, the answer is the cheerleaders can't afford to buy 55 pom-poms and 55 noisemakers. So we solve that by combining like terms, which is part of our objective today. So let's look at the next slide here, where we're going to talk about the distributive property. So you can use the distributive property to solve equations involving parentheses. And we have here two equations, both of them involving parentheses. The first one is negative 21 equals 7 times the quantity of 3 minus x. So let's go ahead and rewrite the original problem here. And then let's distribute the 7 into the quantity of 3 minus x. 7 times 3 is 21, and 7 times a negative x is going to be a negative 7x. So we have to get rid of this 21, correct? And so to get rid of the 21, we're going to subtract 21. And what we do to one side, we need to do to the other. So the positive 21, the negative 21 here are going to have a value of 0. That means that we have the negative 7x that comes down. And negative 21 minus 21, that's the same as negative 21 plus a negative 21, so it's going to get more negative, equals negative 42. Now the negative 7 is tied to the x through multiplication, so we're going to divide, and we're going to divide by the number we wish to get rid of, which is negative 7, and what we do to one side, we're going to do to the other side. Over here on the right, the negative 7s are going to cancel each other, leaving us with just a value with the variable x, and negative divided by negative is positive, and 42 divided by 7 is 6, so we get a positive 6 is the solution. Looking at the second one here, B, on the next slide, we have negative 3 times the quantity of 8 minus 4x equals 12. We just rewrote the original equation. Now let's go ahead and use the distributive property and distribute this negative 3 into the quantity of 8 minus 4x. Negative 3 times positive 8 is a negative 24. And a negative times a negative is a positive, and 3 times 4 is 12, and the x goes along for the ride, so we get positive 12x. Now we need to get rid of this negative 24, and we're going to do that by adding 24 to each side. And what we do to one side, we're going to do to the other. The negative 24 and positive 24 have a value of 0. They cancel each other out because they are opposites. Then the 12x comes down here on the next line. And 24 plus 12 is 36. Now the 12 is tied to the x through multiplication. We're going to use a division to undo that. We're going to divide by the very number we wish to get rid of, which is 12. And what we do to one side, we're going to do to the other. And the 12s are going to cancel each other out, and we end up with just x on the left. And 36 divided by 12 is 3, so the solution is that x equals 3. On example 3 now, we're going to use combining like terms after distributing. So we see the parentheses here, and we realize, okay, we're going to have to do some distributing. And then we're also probably going to have to combine some like terms. So on the first one, let's rewrite the original equation. 5x minus 2 times the quantity of x minus 1 equals 8. This is a negative 2 here, so we're going to distribute that in. Negative 2 times x is going to be negative 2x. And negative 2 times a negative 1, well, that's negative times positive. Or I'm sorry, negative times negative equals a positive. And 2 times 1 is 2, so we get plus 2 here. Now, before we deal with this plus 2, we can go ahead and combine some like terms. Notice that this 5x is in the terms of x, and the negative 2x is in the terms of x. So since these are like terms, we can combine them. 5 minus 2 is 3, and those are in terms of x, so it's 3x. We bring down the plus 2 and the 8. Now we need to get rid of this positive 2. We're going to do that by adding a negative 2 or subtracting 2 from each side. What we do to one side, we do to the other. The positive 2 and negative 2 are going to cancel each other out because they equal 0, and we just have the 3x. 8 minus 2 is 6. Now the 3 is tied to the x through multiplication, so we're going to divide. We're going to divide by the number we wish to get rid of, which is 3. What we do to one side, we do to the other. The 3's are going to cancel each other out, leaving us with x, and 6 divided by 3 is 2. So our solution is x equals 2. Here's a checkpoint. We'll do a couple checkpoint problems here. On the first one, looks like I have terms of n right here, right? I could combine those. 3 plus 2 is 5n. Now let's bring down this negative 40, or minus 40, and we'll bring down our equals 15. We now have a two-step problem now that we've combined those like terms. So let's go ahead and deal with the negative 40 here by adding 40. And what we do to one side, we're going to do to the other. Now the negative 40 and positive 40 are going to cancel each other, leaving us with 5n equals, and 15 plus 40 is 55. So the 5 is tied to the n through multiplication. we're going to go ahead and divide to undo that multiplication. We're going to divide by the very number we wish to get rid of, which is 5. And 55, we want to divide it by 5 also. What we do to one side, we do to the other. 5 is going to cancel each other, leaving us with n, and 55 divided by 5 is 11. So the solution is n equals 11. The second one here involves the distributive property, but over here, this one, number 3, involves the distributive property and combining like terms. So I'm going to go ahead and do number 3 over here. Let's rewrite 13 equals, and we have the 2y. And now let's go ahead and distribute this negative 3 in here. So negative 3 times y is going to be negative 3y. And negative 3 times positive 4, that's a negative times a positive. So that's going to be a negative, and 3 times 4 is 12. Next, we can combine some like terms. So let's go and do that. This is 2y, and this is a negative 3y. So this is 2 minus 3, or we could look at that as 2 plus a negative 3. So we are adding a positive and a negative number, so we actually want to subtract. We want to take that 3 and subtract from it 2 to get 1. And the 3 has a greater absolute value, so the negative 3 has a greater absolute value, so our answer is going to be negative as well. So that's going to be negative 1. So we have negative 1y. But we don't actually want to write that as negative 1y. We just want to write that as negative y. We understand that there is the leading coefficient of 1 there, but we don't have to write it. And then, so we took care of the terms of y, so let's go ahead and bring down that negative 12. So now we need to deal with the negative 12 here, and we're going to do that by adding 12, and what we do to one side, we do to the other. And whenever that's said and done, we're left with negative y over here because the negative 12 and positive 12 cancel each other out. And then we have 13 plus 12 is going to be, what, 25? And now we can't have this in terms of a negative, so we're going to divide that negative y by negative 1 and divide this by negative 1 as well, because what we do to one side we have to do to the other. And negative divided by negative is a positive. Y divided by 1 is y, so now we have the y in positive terms instead of negative. And 25 divided by negative 1, well, that's a positive divided by a negative, so that's going to be negative, and 25 divided by 1 is indeed 25. So y equals negative 25. So that brings us to our guided practice. Whenever we look at our guided practice, it says, what property do you use when you rewrite the equation 6 times the quantity of x plus 1 equals 12 as 6x plus x equals 12? Well, we see that we distributed the 6 into this x plus 1 to get 6 times x is 6x, and 6 times 1 is 6. So here we use the distributive property. Identify the like terms you would combine to solve this equation. Well, we know that like terms have to have identical variable sets, right? Or they could also be constants as well, or like terms. So we have the terms of x here, negative 3 and negative 2. That would be negative 5x. And we could combine those into a negative 5x. Likewise, we could combine the positive 5 and the positive 8 over to a positive 13. We could combine those as well, and then bring that 12. And we don't have to solve that. They just want us to identify the like terms that we combine to get from this over to this. And for the skill check, I'm looking through those. Let me see. Let's pick a couple of them. Let's do number 6, and let's do number 8. So we'll do 6 and we'll do 8. So I have 3 times x plus 1 equals 6. Rewrite the problem. We need to do the distributive property. So distribute that 3 in there, and we get 3 times x is 3x. 3 times 1 is 3 equals 6. Now let's go ahead and subtract 3 from each side, and those will cancel each other out, leaving us with 3x. And 6 minus 3 equals 3. And then we're going to divide both sides by 3 in order to get x equals 1. All right. And then for number 8 over here, let's go ahead and work that in this area here. 5 plus, and let's distribute this 2 in there, right? So 2 times x is 2x. And 2 times negative 2 is going to be a negative 4. And that equals 19. Now we can combine some like terms here. We have the 5 and the negative 4 we can combine. So let's bring down that 2x for now. And then 5 and negative 4 together, that's 5 minus 4 equals 1. So that's still a positive 1 equals 19. Now let's subtract 1 from each side. Those will cancel each other out, leaving us with 2x. And 19 minus 1 is 18. Now let's go ahead and divide by 2. What we do to one side, we do to the other. The 2's cancel each other. We end up with x equals 18 divided by 2 is 9. So our solution is 9. On the next one, the geometry question, it says the perimeter of the rectangle shown is 28 units. Remember, perimeter means the distance around the outside. We start here at one point and we measure from here to here, here to here, here to here, and here to here. That is indeed the perimeter. So we need an equation for the perimeter of the rectangle in terms of x. So let's go ahead and look at that. We know that the perimeter, P for perimeter, and I'm trying to write with a line, so go back to my pen. We know that perimeter is equal to, well, we add up all the sides, right? But we can't really add them up because we don't know what x is at this time. So we do know that half the distance, this side here and this side here, we get by adding these together. So let's put that in parentheses, and we could do 10 plus x plus 2, right? But that's only half of it, so we'd have to multiply it times 2. So we could rewrite this as P equals 2. And then let's go ahead and combine the 10 and the 2 together to get 12. And plus x. So this would be the equation that would show us the perimeter in terms of x, because we have x as our variable. Now it says solve the equation to find the value of x. Well, we know that perimeter, they tell us that perimeter is 28. So we could plug in, for perimeter, we'll plug in 28. And let me see, we'll go ahead and let's erase all this over here. And we'll go ahead and write that over here. So if P is 28, right, and we know that's equal to, and actually I want to go back, I'm going to write it like I have it in the second part here, 2 times 12 plus x, right? Now I can solve for x. So I'm going to have to distribute that 2 in there, right? So 2 times 12 is 24, and 2 times x is 2x, positive 2x. Now I need to subtract 24 from both sides. So minus 24, and that's going to give me 2x on the right, and 28 minus 24 is 4. Now I need to divide by 2, right? Divide both sides by 2. 2's will cancel each other, leaving me with x, and 4 divided by 2 is 2. So I know right here that x equals 2, right? So this side over here must equal 4. So now they want us to find the width of the rectangle, and that's exactly what we did. Right here we found the width of it is 4. All right. So there you have it for lesson 3.2, solve equations having like terms and parentheses. Thank you.